Except for final, but we don't count. Then if you saw this, hopefully you read your notifications or your announcements. If not, I downloaded this yesterday to kind of help you out, save you some time. You still get answers, but notice if I put down everywhere that you could find the answer to the exact question. Okay, so hopefully that helped out a little bit, helping you try to find the answers. Okay. Just a little FYI to be warned about. Because you're going to be doing your assessment on Hawks, Hawks will change the names of things sometimes. Okay, like notice how this says optimal eats, deep fryer has a mean time before failure. If you can't find that one, okay, it's not that I'm like lying to you. It's literally because it's like they changed optimal eats to some other name to make it sound more random, and they may change deep fryer to some other piece of equipment. Okay, so look at the question, but then go, okay, it's not this. It's going to be something that looks like this one. Okay, so just kind of be ready for that. Okay, the same thing is going to happen in your final, so be worry about that. Don't start memorizing, okay, the optimal eats question is this. Well, what are you going to do if it's not optimal eats? Okay, so, and it does that a lot throughout the whole thing. Okay, and then also remember, I do not give you the formulas there. I will give you a sheet of formulas. I will also email the formula sheet to the proctoring locations, but you will not have a formula there to stare in the face, okay? So just FYI about that, just so you know. Everybody good? Any questions over that? Is that straightforward? Okay. All right. Also, people have been turning in their hypothesis test in. Good job. Those of you who've been doing it, good job. When it says work shown, remember work shown could be calculator work. I just need to see all the buttons you're putting down. Okay, if you just show me calculator work of the answer, I'm going to count a lot of it wrong. I need to see what did you put on every single button. Okay, one of them on there is a little weird. I want you to try to do your best. Okay, trying to do your best means if you get it wrong, I'm going to go ahead and probably give you a lot of points. That's turning the critical value into a percentage. Okay, that one can be a little tricky. Okay, it is because, but remember, we learned about one standard deviation, 68%, two standard deviations is this much. You're trying to tell me how much of the complement, how much is inside that. Okay, that's kind of what's happening there. So just kind of do your best on that one. Overall, everything on there should be pretty straightforward. The last two questions don't skimp out. Okay, I think people turned it in, you've done good, but I gave you an example. If you just give me a simple sentence, I'm probably going to count it wrong. Okay, I want to see what is it saying, you know, and then the very last question, it is dealing with what types of errors. Type 1 or type 2. Could you have made an error? Okay, and if so, what type of error and why? Okay, don't just put, well, I could have made a type 1 error. Well, I'm gonna, guess what? I'm gonna give you an error. Okay, so just kind of giving you a heads up on that. I'm gonna gift you a lot of points if you show me stuff. Okay, so don't freak out too much. Remember, this is just a homework grade. Okay, it's not like a quiz grade. Okay, so. Any questions over that? Everybody doing okay? Remember, I did change the time on that. It is due Sunday, 5 o'clock. Okay. I will not accept anything at 5:01. I've given you plenty of time to work on. So at 5:01, if you email it to me, I'm just going to ignore it. Let me know. Okay. All righty, let's finish up. Scatter plots and correlation. We're going to kind of finish up this one. I'm just going to do a very, very quick run through because some of the things you learn in this section you have to have for 12.2. So like I said, I'll just jump through this one pretty quick and then we'll do some of the homework problems and then we'll finish up with 12.2. Okay, remember we were looking at scatter plots. Okay, scatter plots look like that. Remember you have two types of variables. Let's go back to college algebra. What do we call those in college algebra? A independent and a dependent. For us, we're going to call them explanatory, and response, okay? And the explanatory is always going to be your X value. Your response is always going to be your Y value. So there they are there. And the only way this works whenever you're doing a scatter plot is your X has to influence your Y, okay? Like if I was gonna graph how fast I go in my car and then the number of students I have in my class, can you see that I could graph that, right? I could say, here's my speed here on the X-axis, here's the number of students I have. But there's no influence of how fast I drive my car compared to how many students I have. That makes literally zero sense. There is no correlation there. Yet on this one right here, hours of study to test scores, there is correlation there, okay? And we see it, there it is. I gave you all of this right here, I give you a lot of data. On this one, you have to decide which is gonna be your X, which is gonna be your Y. Well, hopefully you can see that obviously height does not affect age. Age affects height, okay? So yes, once you graph this thing out, it's gonna look like that, and there's the data associated. And in this lesson, I tell you, don't worry, you're not gonna have to graph a regression line or a trend line or whatever you wanna call it, and you're still not gonna have to, okay? You can. In 12.2, I'm gonna show you how you could, you know, and if you can't, trust me, if you graphed, well, you did. You graphed in intermediate algebra, you graphed a lot in college algebra. The graphing here is super simple, okay? But we have a trend line. It kind of looks like that, more or less. Okay, it's not perfect. Okay, and that trend line says how close does the data fall right there on that. Okay, obviously we know from taking previous math classes that that line right there would be a positive line, which is why I show you this. A positive slope has a positive linear regression, a negative slope has a negative linear regression. What do you notice about the positive slope? As X goes up, what goes up with it?
Y.
Y. Negative slope, does X still go up?
Yeah.
Yes, but what happens to Y?
Y go down.
Y goes down, okay? X will always be going up, just so you know. Then notice here, I give you some other types of graphs, and this is where you're going to get into your Pearson number here in just a little bit, or the rho. Notice right here the long linear relationship, okay? Because why is it strong? Because most of the data fits almost exactly on that line, okay? This one has a weak one, obviously, because if you drew a regression line in there. Notice the data is kind of more spread. It's kind of gone away from it a little bit. No linear means that if I could draw a line through here, what's happening is these distances just zero out is what's happening here. And you'll see that with the number you calculate here shortly. And then of course, no linear relationship. Well, that one right there is a parabolic relationship. That's beyond the scope of this class and most statistics because that doesn't make any sense. Okay. Good so far, kind of straightforward, right? So really the only real math other than you knowing how to graph X and Y values, which is pretty straightforward, is going to be doing the Pearson correlation coefficient and determination here in a little bit. Well, remember this coefficient says a perfect negative linear relationship of -1. It will never be greater than -1. It will always just equal -1. It means you have a negative slope, but all the data fits perfectly on that line. Okay, I mean perfect, not a waiver, not a 1. 0, that's the one that looks like a big circle. Just there's really no sort of anything on there. And then 1 is a positive slope, a perfect positive slope. So as we approach 1, we know things are getting closer and closer to being a perfect line. As it goes away, it starts to look more and more like a circle. And then as it goes negative, it'll start looking more and more like a negative slope. Okay? Then we took this data here, put it all in our calculator. We knew we had X and Y values, so we put this into our L1 and our L2. If you did not do this yesterday, I'm going to leave that up on the board for about 30 seconds. You need to get your calculator out because your calculator is not going to show you regression if You don't have the diagnostics on, so you need to go there and do that now. Because if you don't have it on now, I will not help you during your final. Go in there. Hit second, then hit 0. That's going to bring up the catalog. Scroll down to where it says diagnostic on. Press enter twice, and then you're done. And then just make sure you're using this function right there, that AX plus B, whenever you scroll down later. Don't use the A plus BX. Okay. So to calculate all this, so if you weren't here the other day, I'm gonna kind of give you a hint on, not a hint, I'm gonna tell you exactly how you calculate this R value. It's very simple. You're gonna go into your stats section, go to your list. You've done that plenty of times. Put in all your data into your list 1, put in all data into your list 2, being very, very careful, obviously. Okay, the more data, the more chances of mistake. Good news, I don't do this much data on your final. I think the most I do is like 6 data points. Okay, so I keep it simple because you only got so much time. Put everything in there. Now, once you put in there, to get to figure out your R value, and this is what's nice, is your calculator literally from now on does all the work for you for everything. Okay, even in 12.2, it's the same process of what I'm about to show you. So you're going to come in here, you're going to hit stat. You're going to hit calc. Okay, and then you're going to scroll down to where it says linear regression, and it's going to be the AX plus B. When you do that, always round to 3 decimal places. Always. That means look at the 4th decimal place to decide what you're going to do with the 3rd decimal place. And you should get R is equal to 0.980. Be real careful on your calculator too, by the way, because the negative value is really small and it's very easy to miss that one. Okay. You should already kind of know what you're going to get though, because look at my X values. My X values are always going to go greater, right? But then look what happens to my Y values here. The Y values are getting greater and greater. They're getting larger now. You can't really see it, but they're getting larger. Okay. So if you put all of this in order. So yes, I have a positive. So how close would this be to a perfect line? Almost dead perfect. Okay, because we scored a 0.98, the biggest score we can get is a 1. If it was a 1, everything's perfect. Okay. So that's how that's done. We'll do a smaller one, so see if you can do it. Make sure you got your diagnostics on, right? Also, very important for 12.2. Okay. Right here, procedure. Determining statistical significance for a Pearson correlation coefficient. A sample correlation coefficient, R, is statistically significant if the absolute value of R, the thing you just calculated, is greater than R of alpha. R of alpha is going to be a chart that I will be giving you on your final. It's also going to be loaded into Hawk. You can click it there. Okay, all you do is you see the R value you created. Okay, they're going to give you a level of significance you need to look for, and then they're going to give you a number of samples. Match those up. See if your number is greater than. If it's greater, you can move forward. Okay, or for us right now in 12.1, it means it's statistically significant. What this means, because I want you to walk out of here with some concept. I don't want you to just be like monkey see, monkey do. Me talking about my speed in my car and the number of students would not be statistically significant. That would be, they'd be like, this means nothing. I would get a really bad score and I'd be like, this is stupid. Why are you trying to put these two together? That you're telling me nothing. Whereas time taking, time studied, and test scores, those would probably be statistically significant. Doesn't mean perfectly. Okay, doesn't mean perfect. It depends on, it really does depend on that R value. It's going to look at the data is what it's going to do. Okay, and the further away your data gets from being a perfect line, the less statistically significant something's going to be. Okay. So doing this as an example, this is one you should probably try if you just came back to class, see if you can get the same R value. So notice age probably does affect bone density, right? So my X value probably should be my age. And then my Y would be that one. But in our case, this is going to be my L1. This is going to be my L2. Calculate your R value, put it into your list function. Like I said, this is a review for some of you, but there was a lot of students gone the other day. Want to make sure everybody's getting everything. And we all see that as X goes up, what's happening to Y? It's going down. So that's a little telltale sign. You're probably going to have a negative line. So you might want to watch out for that. So that way you don't accidentally put a positive in. Okay. Notice you get a R. Let's see if you get the same answer as me. You get R is equal to negative 0.985. You did not get that. Please help a neighbor if they did not get that. Well, remember what our thing says. It says this: the absolute value of R has to be greater than or equal to R of alpha. I think I put that a little too low. I did. Well, this is what it's saying. The absolute value of that negative, and absolute value of any negative is always a positive, always. So take the absolute value of this, and I'm going to get 0.985. And then I notice I've got 1, 2, 3, 4, 5 samples, or they tell me. So I would go here to the 5, and they're saying a level of significance of 0.01. Well, there it is right there. I come over here. Where does it line up? Right there. So that's 0.959. Well, which number is larger? Mine is. So since the absolute value of R is greater than R of alpha, then yes, my data is statistically significant. My explanatory variable, there's a high statistical probability. It is affecting Y. Okay. Then that's how you do it. Now you need to remember how to do that for 12.2 as well. Okay, because 12.2 is going to ask you about this. Was everybody okay finding the R value? Okay, good. As one student said before class, I have no control over the answers Hawks has given you. Be warned, it's a big statement to say your calculator is wrong. There's more of a probability that Hawks is wrong. Okay, they might have done something on the back end or something like that. On your test, I do look at things because sometimes you're going to see some differences, because if you use your calculator, like your inverse T, your critical Z values or stuff like that, or your inverse norm, you're going to get more exacting answers than what you might be getting on Hawks, because they might be using a table. Okay, I will be looking at that because I have a variance on all your answers. That's how come whenever you take your final, you don't get your scores immediately. You won't know what you made. I'm going to put eyes on every single test, so that way I can get partials where I need to. Doesn't matter, okay? Because I'm a human, it's a computer, and people make mistakes, even little bitty rounding mistakes. I'll give you some credit for that. Okay, so don't freak out. Ox doesn't know to do that. If you're supposed to put a 2 and you put a 1, then it's wrong. So now, coefficient of determination, this one is already on your calculator. Okay, you should already see it from the last one. It's just the R squared button. Okay, it's right above your R. Once again, I don't want you to just walk out of here going, okay, we learned some new math today. Okay, well, no, this one actually says something. Okay, and I want to use the last one. Okay, so if I came in here and took the last one, does anybody have a number? What's their R value from the last one? I need it to the 4th decimal place. 0.9845, okay? 0.5 squared. So that would have gave me an R value, R squared, of 0.969. Okay. this is what it's saying. Since you can kind of go back and see the other one, let's kind of go back and look at this. R squared, you see it, right? You can see it on your calculator. So notice here, R squared of 0.969, this is your R squared. R squared says this. Let me go back to the definition. It says R squared is a measure of proportion of the variation in the response variable y that could be associated with the variation in the explanatory variable x. Well, that's just mathy talk. What does that really say? Okay. It's saying this. Notice this is talking about age and bone density. Okay. It's saying there is a 96.9% chance, okay, that the problem with bone density, okay, notice that's my y, right? There's a 96.9% chance that my bone density problem, or the reason it's going down, is because of age. Okay, that means, is there some amount of unknown for the reason of bone density in there that I can't know? I don't know what it is. Yeah, it's the remainder. Okay, it'd be that 3.1% that I don't know about. It's like, I don't know what else. That's what that R squared is saying. It's saying this much of whatever's happening can be attributed to that X. Okay, let's say you had an R squared. I think I gave this example last class. If I had an R value of 0.8, and that's just my R, but my R squared is going to be 0.64. And let's put this as test scores. Okay. Well, my X, that's going to be the hour studied. My Y will be scores. We can all agree that our study should affect. Okay. I can look at this and go, well, at a 0.8, that's saying, my data is not exactly on a straight line. There's some waverability in there, right? But then I need to say, how much can I actually ascribe hours of study to these test scores? Oh, well, look at this, 64%. 64% of the test scores I can attribute to how much studying happens. The remainder, I don't know. I have no idea why you're getting the score you're getting. Is it because you're good at math? Is it because you're cheating? What's going on? But it's there. So that's what that R squared gives you. Okay. So let's do these, and then we're going to get into 12.2. So determine if the correlation, this is an assessment question, by the way, or the final question. Determine if the correlation between the two given variables is likely to be positive, negative, or if they are not likely to display a linear relationship. The intensity of exercise and your heart rate. Well, my first question is, what would be the X?
Exercise. Intensity.
Intensity? Yeah. Intensity, exercise, yeah. Or the level of, like, let's face it, you can go to the gym right now and watch people exercise. Okay? And if they're pro lifting, they're not exercising. Okay? But now you go watch somebody like do like a Tabata routine or HIIT routine, man, they are intense, right? So yeah, that's going to affect your heart rate. So is this going to be positive, negative, or no correlation?
Positive.
Very good. Because as my intensity goes up, what happens to my heart rate? Should go up. If not, go to the doctor. Do I need to graph that, or can you graph? For one, do they give you your X's and Y's already? Yeah, that's pretty straightforward. We can do one, just okay. At 57.5, notice I would come down here just like you would in graphing and go up to, okay, well, let's go up to 4.5. And on Hawks, it's just going to give you, I don't know if you've done for it, 12.1. You just do this, go up there, click it, and it'll put a dot there for you. So you don't have to worry about doing it on paper and worried that I'm going to measure it with a ruler and check to see if you did it right. And you would keep doing that over and over and over again. But just looking at your data, am I going to have a positive or negative slope? Just looking at the data.
Negative.
Why?
Because as the x axis increases, the y axis, which is the interception percentage, decreases.
Yeah, notice those numbers start going down. Okay, so as X goes up, X will always go up. Okay, if it didn't, all the data would be sitting in a straight line up and down, and that would be. There's no, just because you have a straight line up and down doesn't mean you have a linear relationship. They have to go this direction, okay, or this direction, but they cannot go this direction because that's not a function. Okay? That's everybody scored the same thing. Find your R. You told me it was negative, now prove to me it's negative. Non-visually, prove to me mathematically. How are you gonna do your R?
Plus,
Do it. See if you can do it. I know I can. Give you a little hint. There you go. X. You do it or you look at my notes? Good job. Thanks. You don't tell who sometimes who did it on my notes. I'm like that. Make sure you're rounding to the third decimal place too, okay? It will tell you, good news, Hawks does tell you. I love how they give you these rounding rules in your book and then they just tell you to do it the whole time. I'm like. Last semester, I removed all the rounding stuff from the final. Oh my God, I told you what to round to. I remember it. So, negative 0.8, no, that was a horrible 8, so I'm not changing it. What does that say though? Do I have a strong linear relationship, weak linear relationship, moderate? What would you think? I would go strong, maybe strong-ish, but still really strong. If you actually graphed it, and you could, in the last section, you would have graphed this one, okay? I just said strong because all the data, my personal feeling is anything above 75% is going to be relatively strong, okay? Because that means everything's really kind of hovering really close to that trend line. I mean, not everything's going to be touching it, but everything's really close to it, okay? And that's a good thing. And do this one. That's how you're, by the way, how this is what it looks like on Hawks if you use one of theirs. I do believe, I think I have it turned in Hawks. Well, I know I have it turned on in Hawks on your Finder where you can pull up where you can pull up all these. But I don't just let it pull this one up. It's going to pull up every table. You better know which one to go to. And some of them you've never used. It's going to list every possible table that's in that book. Okay. In my defense, I'll let you use a note card. So, is it statistically significant? Well, you don't need your calculator. Do you? They give you an R value. Remember, the absolute value of R has to be greater than or equal to R of alpha. My R is what? Yeah, it's staring at 0.587. Well, what is the other value I'm looking for? I have to scroll down to the end here and look here. And then go where? My 0.5 or 0.01? Yeah, so I look right there and go, oh, so this is going to go right here. Which one's greater? Yeah, mine is. And so is it statistically significant? Yes. Anytime yours is greater is statistically significant. If it's less than or, okay, remember, if it's less than, automatically. Okay, so there you go. How do you feel about 12.1? Pretty straightforward. I mean, it's honestly, once you put this stuff in your calculator once, you're pretty much done. Okay, done. Anybody have any questions over that? All right. linear regression. Okay. Last one. And remember, just FYI, all Hawk stuff closes down on midnight on Sunday. Okay, so if you're behind on homework, Sunday midnight, you're not gonna be able to access Hawks anymore at all. Okay, so get things done soon. No chapter test though. So I didn't put a chapter test this time. Linear regression, that's that line. That line we've been talking about, that's the line. Okay. Let's play with it. Notice, I'm gonna use this data for the whole thing, and then we'll change it. Okay. First off, we can plot all this. Okay. Which one would be my explanatory? Which one would be my response?
Explanatory is class size and response is average test score.
Yeah. Positive or negative? Okay, well, how do you know that? Yeah, the Y's are going down. That's how you really gotta look at it. Once you know your response, look at it. Are they going down? Yeah. So you're gonna have a negative value. So this is what it looks like right there. Okay, so you graph everything, and now you gotta decide what's your trend line. Now, I'll be honest, looking at this one, you could probably guess which one the actual trend line is. Okay, but I would warn you, it can be deceiving. Okay, so the best thing is to not guess on your trend line. Now, why do we do trend lines? It's because what if there's some piece of class size that I want to kind of take a guess about? Okay, like notice there's no 25 on my class size, and I wanted to go, well, what would be probably the average score if I had a class size of 25? Well, looking at a linear regression line, I could go, I think it would roughly be XYZ, this number right there. Okay. Still wouldn't exactly be perfectly accurate because I'm just looking at a line. I don't know an exact number. We're going to learn how to do the exact number today. Okay. You can graph these like I do say in 12.1. Graphing these is going to be beyond this class. Once upon a time in this class, one of the professors made you graph it. Okay, by hand, which was not hard. Okay, you're going to see why. If you take an intermediate algebra at this school, you know how to graph them already. Guarantee. I'll show you here shortly. So here we are. Definition: least squares regression line. Okay, the least squares regression line is the line for which the average variation from the data is the smallest, also called the line of best fit, given by y hat equals b not b sub 0 plus b sub 1 x. Okay, common math symbols. This is how you might see these. Some of those should look kind of familiar, especially like look at the second one. Y equals mx plus b. You remember what that used to be called? Huh? Slope what?
Intercept.
Slope intercept form. Only difference is we're using a y hat. Okay. You should also notice something else on there. What is the function you've been using on your calculator? Ln reg what? Ax plus b. Looks like it's on here as well. Okay. Remember, every time you've been calculating your regression, you've been getting that r at the bottom, right? You've been getting an r squared. Why don't you ask what the a and b are? There they are. Okay, so these are, it's already giving you your A and your B, so that's the good news. Okay, so the calculator work is still going to be exactly the same. It's going to be go to stat, okay, put in all your information, and then go to that Lin reg one, okay, AX plus B. Now I put this down, I copied this very last sentence from your book because I really thought it was very poignant. One, you're going to have to, before you do any sort of regression in your homework and possibly even, yes, on your final, you need to decide, well, and do I even need to do the line? Okay, so you have to find out, is the data you're about to use, is it statistically significant? Okay, which is why I really do like what it says right here. What happens if the correlation coefficient between two variables is not statistically significant? If R fails to be statistically significant, then the results are not meaningful enough to use. Okay, in other words, there is not a strong enough linear relationship shown by the data to determine that there is a correlation between the two variables. In parentheses or in italics, linear regression should not be used to model the relation between two variables if R is not statistically significant. The reason I put that in there, day 2 of class, maybe day 3 of this class, I said to you, if I could let you leave this class, I want you to leave with your BS meter better. You should be able to start hearing things now and go, that sounds weird. I don't know why that sounds weird, but that sounds weird to me. And be able to at least ask some important questions. How many times do you see linear, probably scatter plots online? And you're like, oh, okay, those look, yeah, it looks legit. Is it? Is it really legit? Do you know? Because once again, I gave you a scatter plot earlier of how fast I drive in my car at different times and the number of students I have. Those have literally zero correlation, but I could graph it and tell you a story and you'd be like, oh yeah, sounds legit. But there's literally no correlation, but I can still graph it. And so this is what it's saying. If you do an R value of some data you see, if you're looking at something going, I don't know if that sounds legit, grab out your calculator or go to an Excel program, calculate the R value, do R squared, do all that kind of stuff and go, there's no correlation here. This is, why are they even showing me this? This is stupid. But you can also kind of use your intuition too. You know, that's how come that one says level of intensity and heart rate. You can kind of see there's a correlation there. Okay, so this is just another way to you kind of go, okay, I need to be paying attention to things a little bit more closely if somebody's trying to teach me something on TikTok, Facebook, whatever you're on, and whatever's coming. Well, once again, using this information, let us find out which is going to be the best fit. Okay, so the first thing we're going to do is, once again, I want you to find out if there is a significant linear relationship. I'm going to give you the 0.05. You're going to figure out my R value. So get to figuring. Start putting everything into your calculator. You've got an L1 here and you have an L2. And you needed to find out, is this information statistically significant? Okay. For this thing right here, to find that, you'd be using the Pearson correlation coefficient table. I'm going to give you that number. You will be given that table on your test. That's going to be my R of alpha, and that R of alpha at a 0.05 level of significance with a data value of 1, 2, 3, 4, 5, 6, 7, 8 is going to be 0.707. Should know it's going to be a negative. We talked about that at the beginning of class. As X got larger, Y got smaller. So that should give you an idea like, oh, going to get a negative number in here. Did you get R is equal to negative 0.978? Okay. Well, looking at just my R value, how close does my data fall in a straight line? It's going to be really, really close. Okay. Notice the absolute value of any negative number is a positive, so I'm looking to see a 0.978. Is it less than or smaller than 0.707? Hopefully you can all see. That is larger. So is this statistically significant? Yes. That means you can move to step 2. Okay. If it's not, you stop. Because literally, why are you trying to make something of significance that one thing has no effect on the other? You're literally just talking at that point. You know, I give it to my students in intermediate. I teach them the value of I don't know. I go, I don't know is very undervalued. Okay, people just like to talk to sound smart. You know, like I heard a sound in the woods. I don't know what it was. I think it was Bigfoot. And I quit listening. If you say the words I don't know to me, my brain really starts hearing seagulls. Because I'm like, why are you still talking? If you don't know, then I'm not listening to you anymore. This is the same thing. If there's not a level of significance, why are they still trying to do anything? You're done listening. You don't care what they have to say at that point. So, step 2. If the relationship is significant, find the least squares regression line from your calculator. This is what it says. Okay. What it should be reading right now on your screen, if you're still on the R page where you saw everything, should say this. Y is equal to, more or less, depending on your calculator, AX plus B. It's letting you know which formula it's using. Okay. And then it gives you an A value of negative 1.043. And then it gives you a B value of 103.085. Did you get that? Okay. This is what you would put, well, this is what you put on your test. Okay. FYI. Cox uses this one. Okay. That's the one they use. So remember, this right here would be your A, this right here would be your B. Okay. Your calculator uses the AX plus B. Okay. I want to give you all a hint of it. So realize what you're seeing here is this. Y hat is equal to, well, my A is going to be the negative 1.043 X plus 103.085. Can any of you past algebra students tell me what this is? Slope. Exactly. And what is this right here?
Peterson?
Very good. Is that not the equation of a line? This equation would literally say this, what? I'm going to go down negative 1.043 and then do what? Go over 1. And as I keep doing that, it's going to cross at the y-intercept at 0, 103.085. Isn't that how you create a line? And that's exactly how you would do a regression line. If you were in Desmos, which I'm hopefully, every single one of you should know how to use Desmos, right? Did y'all use it a lot in college algebra at all? Okay. You plug that into Desmos, you're going to get a straight line. You can also scatter plot all your data, and you're going to see, oh, there's my linear regression line, okay? Which I will show it to you now. There's our line. Like I said, remember, Hawks uses the other one. They're using the B naught plus B1X. That's how come it looks differently, okay? But you're using the AX plus B, so don't worry about it. It's going to work out just fine. And as I told students yesterday, well, first off, it's not on your final. Okay, so that's good news. I don't give you a question like that. One of your questions on your homework does say this, put this in the form of, or solve for something, and it doesn't give you A or B, it gives you a B sub 0 and a B sub 1. It's using the old formula, okay? There we go. Now we can look at it. And man, when you see it, you can go, okay, man, that's 0.89. Yeah, I can see what that looks like now. Look how everything's kind of hugging, the line. It's not perfectly touching it, but it's hugging it. It's right there. Okay. Once you have this, you can start inferring a lot. Okay. There's a lot of inferences that you can start making towards certain things, but you got to be careful. There are some rules, okay, that you have to follow. 1, you got to make sure that the data do not fall in a linear pattern when graphed on a scatter, okay? So prediction should not be made with the regression model if the data do not fall in a linear pattern. Basically, remember, if you do your R and you get a 0, you don't have a linear anymore. You've got just that circle of stuff. I would almost say anything less than, like, say, I don't know, 40%. The closer you get to zero, the less you should be doing it. Okay, but then don't forget, you still got to look at that statistically significant. So that's going to become a really big thing. Notice number 2, it's got to be statistically significant. 3, this is where they'll get you in hogs. You wish to make a prediction about a value about outside the range. Okay, notice here, I have a range of numbers. My range is between 15 and 29 inclusively. I cannot make any sort of judgment on anything outside that. Just because you created a regression line doesn't mean you created an infinite line like a linear function. You created a little small segment of a line that is dealing with this amount of data only. You can't step outside that. I can't suddenly go up here and go, well, I wonder what would happen to a class size of 10. I'm outside my range now. I can't do that. What happens to 30? I don't know. I can't decide that. What happens to 25? Now that I can test because it's within that range inclusively. The population is different from that of which the sample was drawn. You can't start talking about NMJC and me get regression models for NMJC and then go, I wonder what's happening at USW. It sounds like a duh statement. You'd be surprised how many times there's a Reddit forum I follow called Bad Stats. And this is the one that pops up the most. Every day, some major news organization on both sides of it throw up linear regression models and they're not using the same data. They're going, we found this regression model for this thing that this president did at this time. And then they start talking about another president. I'm like, that's not how that works. I can't compare you to her. I need to compare you to you. And then her to her. Okay, that's how that works. Look at this one right here. Let's do some really quick ones here. You can make predictions. You have a formula now. It's just like what you do with functions. Remember, a function said this: give me an x and I'll give you what? A y value, right? Same thing. Give me an x, I'll give you a y. Well, let's look at this one. If you plug in 16, what are you going to get? Well, I get y hat is equal to 103.085 minus 1.043 times 16. Plug all that in and see what you get.
$86.40.
Very good. 86.40. Once again, let's do another one. Let's do 19. Do the same thing. Y hat 103.085 minus 1.043 times 19 is equal to
83.27.
How about the 25? Let's do it. How's that sound? You do it? Why? Why are you trying to do a neighboring district whenever you were trying to work on your district? Fox just fooled you. Can't even do it because you're trying to compare this district to some neighboring district. No, you got to worry about your district. So that one cannot be done. That would be going against, I think, rule number 3. That's all right. Let's do class 45. How's that sound? Someone else got tricked. My highest data point 29. Why'd you go outside my values? Got to look at your data. I don't know what's going to happen at 45 because my data stopped at 29. That's my cutoff. I can't go anywhere past 29. So 45 is outside the range of possibilities. I cannot make any inferences to anything beyond that. Why is that? Because if you start adding values, your regression changes. Your R-squared changes. Your significance changes. Everything starts changing as you start adding data. Okay? So that's how come they keep you bounded inside just this area and you can't go outside. Okay? Let's do a homework problem. You're gonna have like 7 homework problems, and they kind of go back to 10-5, how you had like 6 questions, or like again 1 question but had like 6 parts. Good news. Most of them, your calculator gives you right off the bat. Okay, that's the good news. Just not in order. Find the estimated slope around your estimate of 3 decimal places. Well, how are you gonna find the slope? Isn't it the same way you find R? Which means I need to find out, hey, isn't this going to be my X? This is my Y. And yes, I get it. Your calculator doesn't need X's and Y. I want you to start seeing the X's and Y's. Okay? Does hours unsupervised, does that affect grades, or do grades, overall grades affect my hours unsupervised? Does that make any sense what I just said at the end? No. Hours unsupervised affect grades. Look at the formula they're using, because some of these do switch out on yours, and you'll say solve for something and they're going to want to say this the B of 0 or whatever. So when you get your calculator info, I'm gonna give it to you one time, and let's see if you got the same thing. This is what your calculator should be saying. First off, you're using the AX plus B. Your A is equal to negative 7.638. Your B is equal to 103.655. R squared is 0.973. R is equal to negative 0.986. Hey, how close does my data fall into a line?
Pretty close.
It's gonna be like super, super close, okay? How much would you say that hours unsupervised, or my grades are affected, okay, by hours I'm unsupervised? Yeah, I would say, man, 97%, that's a lot, okay? Sure, there's about, what, 2.7% in there that I can't account for, but that's not very much. That's almost that's meaningless at 2%. So, what would be your slope? Yeah, it's your A value, right? Because look, your A is your slope. Your B is your what? Yeah, your y-intercept. Okay, so yes, your A would be the negative 7.638. That would be the answer you would put on that part right there. And then you go to part 2. So keep your numbers in your calculator. What's the y-intercept? Should be staring at it. You should be looking at it right now on your calculator. 103 point what? 650. Very good. Now look, most of this is going to be in your calculator. It's going to be right there staring at you. Okay? But then you got this part. Substitute the values you found in steps 1 and 2 into the equation for the regression line to find the estimated linear model. According to this model, if the value of the independent variable, independent is always your what variable? Your X, is increased by 1 unit, then find the change in the dependent variable Y. Okay. I'll show you the math of this, but then hopefully somebody kicks in and goes, well, wait a minute. Okay. You have a formula back in time. I'm going to show you the more mathy version. You're going to get it now. Called delta Y all over delta X, which should be actually more akin to this. Y2 minus Y1 all over. Anybody finish that off? X2 minus what? X1. What is that formula? Soon we forget. Put it in, what would it be? Y equals mx plus b. What's your m in that? Slope. I just gave you the slope formula, right? So look at it here. If you give me 2 y values and give me 2 x values, I can find the slope of anything, right? We'll look at it very carefully here. What does it say? Hey, let's just do this. If it says, if I increase the x values by 1, okay, well, that means this. I have a formula that says this. Y hat is equal to, well, my slope is negative 7.638. What do I need to put next? Supposed to be an X there, right? I'm gonna put a parenthesis there, because I'm about to fill in that. And then I get a plus 103.655. Well, that should equal something. Well, notice, let's use one of these. I've got 1.5 there, right? We'll put it in there, 1.5. Calculate that out and give me a number. But you got to do it again. And that X value has to increase by 1. They give us the increase by 1. It's going to be at 2.5 and plus 103.655. And then what do we get?
$92.198.
92.198. How about the second one?
$84.56.
Okay, well, didn't you just give me a Y2 and a Y1, right? This right here, that 1.5 and that 2.5, well, that's gonna be my X2, that's my X1. Here is my what? My Y2, and then my what? Sorry. Y2 and then my Y1. Well, can't you just put that into your formula? Well, put it in there, 84.56 minus 92.198 all over 2.5 minus 1.5. That's going to just equal what on the bottom? 1, right? Isn't that what it said though? Look what it said right here. The variable is increased by 1 unit. What number do you get?
7.16.
Where's that at? But the whole time I've been telling you, you've been calculating the slope, it's been the A value the whole time. Remember, your slope is your A. Okay? But what is that saying then? Because sometimes on Hops, it's gonna say, what does this mean? For every hour you're unsupervised, what happens to your grade?
It's down by.
Roughly what?
7 points.
7 points. Every hour a student is unsupervised, that means parents aren't hovering over you like the overlords that they are. And you're just giving carte blanche with your time, what's gonna roughly happen to your grade? It drops 7 points. For every hour. That would be interesting to actually find out. Determine if the statement, not all points predicted by the linear model fall on the same line, is true or false. First off, what do you think? I'm gonna go with what you think and I'll tell you what it is. Where'd you get your data? Did you get it right there? Did you plug that data into your calculator? Did you get data from anywhere else to plug into there all of a sudden just now? No. So this would be false. Because to get this data, to get my A value, didn't I use this information? To get my B value, did I use this information? Getting my A and B, did that create me a linear model that I could use to create the regression line? Yeah. So no. All the points I have are from this. So no, this is going to be a false statement. Does that make sense? Okay. Find the estimated value of y when x is equal to 3. All you do is use your thing, right? Y hat is equal to negative 7.638 x plus 103.655. What am I going to do for that x value? I'm plugging in what there? 3. And what do you get?
7.1.
Don't fall into the trap of looking at that 3 and looking at 77. Okay. The reason, hear me out, the reason that's, you're not getting a 77 there, okay, is this. That's a data point. That's an actual real number, okay, a real number. At 3 hours, we examined this, okay? Here's 3 right here. Here's 77 here, roughly. Right there. Okay, your number is on the line. Their actual number might be sitting there. It's a data point that's a little bit below the line. Because remember, that regression line is kind of going in between the data a little bit, okay? That's how come you're not getting the exact same numbers. Okay, so just kind of be warned about that. I do want to show you something because this does happen on your final. And I don't know if I gave you a question. Remember, not all the questions are on your review. Okay, I gave you all the hard questions. There's going to be some very simple, straightforward, easy questions. But let's be honest. If I gave you this, my very good algebra students, we just solved for y. Can we agree? Well, if I gave you this, 80.741 is equal to negative 7.638 x plus 103.655. Could you solve for x? Yeah. Subtract 103.655 from both sides, right? Divide off the negative 7.63, and then you would come back and get your x value. That is one of your type of questions on your final. Okay, and there may be a review question that says that, but it's basically, it's going to give you a formula, and it's going to say, hey, what is this if I give you this? Okay, and you're going to have to say, well, if I plug it into the x, it's solved like normal. But if they make you plug that guy into the y, now you're solving for x. So just kind of be careful about that. And it does tell you explicitly, this should go here because even in parentheses, it says what it is. The only annoying thing I found, and I do not give you this question on your final, I don't think so. There was an annoying one because I always do y'all's homework before y'all get to it. And I got really annoyed at this question in Hawks because they give you numbers into the hundreds of thousands. And so what would you think to do? Plug in 100,000 over here, plug in everything, solve. It does not work that way. They want you to get rid of the zeros. And I'm like, that makes no sense because it doesn't tell you explicitly ever do it. I even went through the tutor button. I went through the learn. I went through the solutions. Never did it say it. So if it does that to you, do what they say, and then throw that question outside of your head. Okay, I don't like the format of that question. I will probably try to remove it in the future. I can't right now. Once the class is live, that's all you got. Last question. Find the value of the coefficient of determination around your answer to 3 decimal places. Well, do you need to find it or are you staring at it right now on your calculator?
Calculator.
What's it say on your calculator? And what is your coefficient of determination? It's going to be your what? R squared, not your R value, it's your R squared. 0.97 what? Exactly. So that says right there, R squared says 97.3. That means 97.3% of my overall grades can be explained by what? Hours unsupervised. But there is a level in there that I don't know what's going on. All right, so review. Your project's due by 5 o'clock on Sunday. As I've said before, 5:01, I'm not taking it. Don't email me. I don't care what goes on. I don't care if it's my internet. I didn't have internet. You're a liar. There's internet in Hop somewhere. Go to Starbucks, get a water. Okay? There's somewhere where you can turn it in. Hop shuts down at 11:59 on Sunday. Anything not turned in goes to a 0. Okay? Your final is on Monday?
Yep,
Is it Monday at 8:30, I believe, right? Okay, should you double check that just in case? I will be, okay, because I want to make sure I'm here.